session entitled Tech and Artificial Intelligence and Innovation in BTR, which are a lot of big words for what is a very big topic. So as introduction, my name is Ashley Perry, Investment Director at Apache, and also the Vice Chair of the UKAA Investor Lender Forum, if you were in the earlier session, so I touched on our activities in that space. Very pleased to be joined by Jana from Consigli, Rajesh from Quintain, and Dave from Clarion. At the appropriate time, we'll make sure that we allow themselves to introduce themselves. So we've got a brief introduction presentation from Consigli, so I'll let them sort of let Jana explain exactly what they do, and then we'll get into flow of questions, and then hopefully have 5 or so minutes at the end to chime in with any great ideas that might be relevant to this topic. So, Jana, if you wanted to lead things off.
Thank you.
Hopefully the technology works.
Yeah. Sometimes PowerPoint is the hardest part, isn't it? Yes, so I'm Jana. I'm the founder and CEO of Consigli. We have built something we call the autonomous engineer. And I have to apologize beforehand, some of the examples that we have are from commercial real estate. It's because we're showing not like something we just made, it's real projects, and to have clients exposing their project and data is not always easy. So bear with me on that. Yeah, just to be sure, AI, tech, there's a lot of things going on now. It's really, really exciting. We have taken the angle that we are real estate first, so our AI is to reduce cost, risk, and carbon footprint in projects, because I think that is the most important thing we do when it comes to development projects. So the AI is mostly for development phase, but it's also within O&M, and I was here earlier and heard about the Fire Safety Act being explained, and we've made a tool for that as well to help you all with some of that heavy lifting. Yeah, so the autonomous engineer, she has learned quite a lot already. I'm going to just give precise examples of how we can use AI in what we normally do in the development projects anyway, and how we can get help. So just a really, really fast and accurate and smart assistant. Our aim is to move real estate from that left-hand side to the right-hand side, like they've done in the automotive industry, where they have machines doing the engineering and not humans. We are currently using humans for more or less all of the design, and ending up on the right-hand side, spending way too much material, way too much embodied carbon footprint, and also carbon footprint in operation due to the long stretches of ducts and pipes, etc. So some easy things that we can use AI for already, checking out whether what the architect has modeled or drawn actually matches our requirements. Sometimes hard to take that written documentation and then look at a model or the drawing and see, is it exactly the same? The machine is really good at it because it makes both sources into data and then do the comparison and can give us the statistics, so we can actually see where there is any deviation and go back to the architect and say, well, love your work, but please work on these areas, because we need to get the areas that we need, the spaces that we actually need for the use of the building. Another example is shuffling. This has nothing to do with architecture, it has only to do with mathematics. Shuffling boxes, so standardized units, hotel rooms, social housing, all those standardized units, shuffling those into the maximum amount you can get it within a building envelope is actually pure mathematics, and that's what we made AI for. In this specific hotel, we were able to find 24 more rooms in this tiny building using the AI instead of when we compared to what the manual team was able to make. And that is a lot of extra value for the developers, actually £7 million for this rather small hotel in the middle of Oslo city. The thing is also, because we did it early, we could have that discussion whether we should actually have a smaller building envelope to allow for more light and better fire conditions in that backyard, and ended up with still 24 more rooms, but just a better building, better light into the rooms, etc. And it's really fast. So you can do it at that early stage and shuffle around quite a few times without it costing too much, without it costing too much time. Sorry if I do this quickly, because I think I'm only allowed for 10 minutes to tell about everything amazing.
You can stretch to 15, no worries.
Okay, good. Good. And then we have all these ceilings, right? We need to fit in the fan coil units. We need to get everything cramped up in that ceiling, and still we want as high ceiling as possible, right? So we built a machine so that it can go in and take all the equipment that is going into that void and then make a smaller void. In this hotel in a luxury residential apartment here in London, we were able to take the ceiling up 15 centimeters, which is extra value for the developer, right? It's space and volume that we don't actually need. And then having the machine fit everything together, there's no magic. It's just that it tries out billions of iterations and then presents us with the best one. And of course, we cannot have humans trying out billions of iterations, and we will never be finished. So it's just a perfect place where we can go in with AI and get help. And then we have the most advanced AI that we have is that if you have the architectural model and you're going to get in, this is a commercial building, are doing the same also in residential. But if we have the architectural model, we actually know everything that needs to go in to figure out of the whole M&E system. Because we know the laws of physics, we know the materials, we know the requirements, we know the regulations. So it's just a situation where we have a really high complexity, but of knowns. And that's the sweet spot for AI. If everything is known, it's just that it's really, really complex, then AI can calculate and find the best solution really quickly. So in this case, we got the architectural model, and then based on that, we placed all the lighting in the ceiling, air in, air out, fire detector, sprinkler, everything. And then we use pathfinding, so like in gaming, fastest route to find the stretches. And of course, because of the capacity for this machine, it does the pressure loss calculations, it does all the math all the way, so you get the right dimensions, and it lays it out. And normally, when we do comparison with projects that has been designed by humans, we're not at 70% reduction yet, but we're at 20% reduction of components, because it has optimized the placement and the number of components in the ceiling grid, and also 20% reduction in stretches of ducts and pipes, etc. So this is a massive cost efficiency, embodied carbon efficiency, and also a carbon footprint in operation because of shorter stretches to push water and air. And I think the most sustainable we can do is do with less, right? This is all early stage, REBA stage 3 design. And then if you go further and choose right material and all of that, that's how we can do sustainability and cost reduction at once. We stop at REBA stage 3 because we cannot get insurance for the detailed design. We could do it technically. But for that, I guess a lot of the people in this room, developers, would take it to REBA stage 3 anyway, and then go for tendering. And then we have those plant rooms. We have technology so we can have those plant rooms the right size, so everything fits. It's a good room to operate, and you can do everything, but it's not bigger than it has to be, because bigger than it has to be has extra cost and extra carbon footprint. So here we're taking mathematics from the shipping industry. When they make these model rooms of ships, they don't have a huge team of engineers doing each discipline. They have it all at once and do it mathematically. So in this case as well, we have reductions up to 50%, purely on stacking everything in the right way, allowing for service spaces and operation and maintenance as well. So those are engineering tasks where we can get really, really good help from AI. But we also have some heavy lifting when it comes to documents, right? All that documentation going into the tender. We made a machine that can take all that tender documentation, mix it into data, and then we look for, is everything correct? Are there any discrepancies between the documents? Are all the references to standards, to valid standards? the wording, is it correct or is it vague? So everything it finds based on domain knowledge that can create a risk in the tender or in the contract with the contractor, it would show. And then it's up to us as humans to decide what to do with it. But if you want to have a closer look, you can simply open the documents and see that it's actually there. So you don't have to think about whether AI is correct or not. You can see it's actually there, and then you can add an email address or get it sent to the person who needs to be responsible also for updating that document. So it goes right into the way we work today. It's just that all that reading, finding, and sorting, the machine can do, and we see that it does it a lot better than we're able to do as humans. And then we have the same functionality for the O&M documentation that you get when the building is finished. So the machine goes through everything, figures out whether everything is there, if it's the right format, version, everything, so that you can go back and send it to the contractor to get it completed if there is anything that is missing or not correct. And we can also sort the documentation into that classification that you need to have in the O&M system and retrieve all the tasks that has been specified in the document, so you also get those tasks into the operation and get it all set up. So the handover from development to operation and maintenance, AI can help us a lot to improve. And because we started to do that, and then we came, this technology has been made in Scandinavia, and then we entered UK this year, and then we learned about the Fire Safety Act. And to show compliance with the Fire Safety Act, you actually need to go into the O&M, right, and retrieve a lot of information there, sort the documentation, and get it all set up so you can show compliance. So we have taught the machine to do that. So it goes in and see, is anything missing? And from everything that is there, it can sort it and make all the safety case evidence automatically. So all that heavy lifting, we're reading and finding and noting and all of that, you don't have to do it anymore because we've trained the machine to do it. But of course, we need a human to control it and set it up and help. But you can get help doing that job that you probably don't want to do. And then because we're doing all of this, we made all that document into data. We trained large language models or data models on that O&M. So we have gone to OpenAI. We have the technology that lays within the ChatGPT, and we use that in the use case, in our user interface, so you can actually talk to your documentation. So you don't need a digital twin in operation and maintenance anymore. You can have the O&M that you have anyway, make it into data, and then you can talk to your building instead. All within the same safe data that you have for that building. So this is not something that goes out at public ChatGPT. It's all within the closed environment of that O&M documentation. It's quite amazing, so I'm letting it go, right?
Yeah, absolutely.
Yeah, you want to talk to your building, right?
Why not?
Yeah. This is our UK team. Jørgen is here. So it was a quick intro, and I'm really eager to hear what these gentlemen are going to talk about this.
Terrific. Thank you, Anna.
Thank you.
Plenty to ponder there in terms of the painstaking process of pulling together data rooms and tender information for lots of people in the room. So thank you for that, Jana. Lots to think about the impact of AI on that. I think it'd be useful, Dave, if we can get your view on what you guys are up to in digital design and actually delivering, and how that's sort of how a lot of your work is actually impacting things on site from Clarion's perspective.
Right. Well, as a bit of background, I mean, I'm more from a private sector kind of workforce all my life. For the last 20 years, I've been doing digital strategies for the likes of AECOM and Skanska and Mace and all these kind of guys. I'm going to say something I really shouldn't. Every single digital strategy has been the same, right? That's not me being lazy, okay? That's basically the principles of digital architecture. And it's nice and simple. It's 5 steps in the same order every single time. It's define, capture, validate, analyze, utilize. The difference is the company and their focus, their business focus. So if you're an architect or an engineer or a contractor, you focus on the second one, capture. How do I give the information across? Yeah. For Clarion Housing, we care more about de-risk and agility and everything else. We focus on definition and validation, right? Either side of that capture zone which we're getting from the industry. So when we've been looking at this great tool from Consigli, that validation piece for us, this is something that we've been lacking in the industry for a long time. Checking all of them thousands of pieces of data that come back. Truth be told, we don't do it. Yeah? AI and everything else that's coming in allows us that kind of flexibility and the rigidity to do that act that we've never done before. So that's our major focus, and then that brings us back to the first one, which is briefing. Definition, how to give across a very clear definition of what it is that we actually want. Yeah? And to me, you have to work backwards. So if I'm going to check something, I want to be able to tell you very, very clearly how I'm going to check that. Mm-hmm. Yeah? And this is where our kind of crossover comes in with the automation and everything like that. If people know how I'm going to check that, they can actually align their process to make sure it's right first time. Yeah? So it's a slight change. It's not just me copying and pasting and doing a save as of every documentation that we do, but we see it very differently in Clarion. And it is changing vastly the outcome of what we're producing now in our new buildings, especially with the legislation coming in with the Building Safety Act and everything else.
Yeah. And Rajesh, from your perspective, maybe talk us through how Quintain's learned from an operational portfolio and how you guys have designed and delivered with some very sophisticated assets and models and everything else in terms of how things have moved on with a large operational portfolio. Perhaps if you could talk us through how elements of what we've talked about here with the presentation, but also from, I guess, the customer journey through to operations. I think that's where we'd like to hear your perspective.
Absolutely. Hi, everyone. I'm Rajesh Shah, Executive Commercial Director at Quintain. So we are a mixed-use developer at Wembley Park. We're a developer and operator, and I'll come into the link behind that. But across our site, when I say mixed-use, we've got retail, we've got commercial, student, leisure, but the predominant piece is residential. We built over 5,000 residential units so far, of which just over 3,600 are built-to-rent, covering 10 developments. So how it comes into play is really the first built-to-rent development opened in 2016. So we have 7 years of history across 10 developments, all with different styles and mix and amenities. And one thing about our business is we are data curious, we are data hungry. So what we love doing is collecting data points. One of the challenges, though, is that the data is collected in multiple different systems. So how do we find a way to integrate it? And one of the things you talked about, having a tool set which will take, I made a list on my way in today about all the data we collect, and I wrote about 30 items, realized I barely scratched the surface. And everything from the building-related design, captured in BIM models, the furniture we put in place, window dressing, the floorings, bathroom, kitchens, door sets, operational information from marketing, leasing, maintenance. So that data set is vast, demographics on top. So how do we take all of that and keep continuously improving? And what we just really think about is the objective. It's all about resident customer experience, trying to bring operational efficiency and then converting back into design. So it's literally a continuous loop. And we've been trying to capture a lot of this information, maybe in your sense, in old form, which is lots of documentation about our design guide. So we have a very detailed design brief, MEP brief, ICT brief, standardization documents, but they all assume a static point in time because the world keeps moving very fast. And part of the journey is we have to keep moving with that. And to give you some examples, actually, to your question, so if you take utilities, we capture every 6 minutes across 4 meters for every single apartment. That's a ton of data coming every day, every month, and we've been doing this for 2.5 years. The data is vast, and it's, it has huge potential behind it, but we barely scratch the surface about what we do with that. So, for example, one of the things we've been trying is gamification. How do we incentivize our residents to understand if I live in a one-bed apartment, what's my usage compared to someone else who lives also in a one-bed apartment in the same building? And really through that angle, and how do we make are buildings and operations sustainable? How do you incentivize residents to come on the journey with us? But equally take that data into design. So we have a lot of consultants who look at the heating and cooling elements into the buildings we're designing, but I never hear about them taking data from the real world and actually testing it against their theory. So how do you use this vast data to try and bring a continuous loop into that? If you take furniture, we asset tag all of our furniture. So one of the beauties is every time you go in for tender, we know these materials work or don't work. We know this particular item of furniture never touch again. And it just means from a customer journey, we're always giving them something better. And the bit we really, I would still say early stage of the journey is using sensors. In one of our buildings, we have an entire amenity floor, and we put a ton of sensors in there. And again, the data's flowing. So teaching us about, where we think work at home works with a table and 4 chairs around it, you might find people work at home in multiple different ways. What time of the day do they work? Bizarre things like, what's the toilet provision you need to have on the floor? So this data, the journey is ongoing, but at the moment we made lots of inroads, and part of the task I'm trying to have is really collecting all this in a consolidated way and make more out of it.
Very interesting. Thank you, Rajesh. Jana, perhaps you touched on it there around where you fit into the REBA stages and that you sort of take it to stage 3, but perhaps if you could give us a bit more sort of, I guess, fitting into maybe a tangible project that you're working on where, I guess, what stage is the most appropriate point, perhaps for people in the room that might have use for the product? Where's the best time to talk to you guys?
For us, the sweet spot is to come in end of REBA stage 2, because then you have the architectural model, you've done the planning, everything is set with the geometry, and then because of we're not going into architecture at all, there's plenty of other AI applications there now for architecture, which is really, really good. People knows about architecture. People don't know that all these technical systems are actually engineered by somebody. So that has allowed us to be early and making the machine. So end of stage 2 to do the planning, and then we also, because every project is different, right? Sometimes what you need to optimize that project on varies. So we will always sit down. It's a man-machine collaboration. So we sit down so we know that our people totally understand what is important in this project, and then we will ask the machine to optimize on those parameters. And then we can do the stage 3 M&E design, and then going. Sometimes you know already early what kind of components are going into the plant rooms and or into the ceilings, and then we can do the optimization. Otherwise, we will have to wait until stage 4. And then, of course, in the tendering. For a lot of developers, we come in and then we do that, and then we check the O&M, and then they also say, oh, we have all these existing buildings. We know the O&M is not necessarily what it should be. Can you help us just go through what do we have, what is missing? Can you sort it and help there as well? But I think our approach is to go in, because I've been in this industry for 25 years, so we come from the industry, trying to solve real issues that I know, and we know that is there, that they're real, and those are the ones we have solved first. So taking low-hanging fruits instead of going in and say, oh, AI can solve anything. We are very specific on solving these for now, and then we have a massive development going on, of course. But end of stage 2, go in, or if you have a lot of buildings that you are now struggling with Fire Safety Act, or just the general sorting of the O&M and getting a real grip on all that data. And then, like you said, this is an industry that doesn't lack data. It's just we have so much data. That's normally the issue when you make AI, that you don't have enough data. But we do have a lot of data in this industry. It's just a matter of utilizing it, using it for something, so we get insights. And then we can teach the machine everything that we struggle with teaching humans, because it's so massive, so it can help on that as well. But the amount of data we have is enormous in this industry, which is good. Very
good. And Dave, on the pre-call, not that I was able to join, but I listened through to it a couple of days ago. You touched on the process that typical UK developer goes through, the design and report process, sort of design and then check back and kind of play around with that. how is sort of what you're doing with Clarion, and presumably some of your other peers doing, what is that doing in terms of actually delivering better outcomes on site, whether it's coordination or end user experience?
Right. So
touch on that.
The concept that you're talking about now, I mean, it's kind of a new phrase, but it's informed design, right? So if there's architects in the room, they'll have probably heard of that. For generations, we've always been doing what I would call reportive design, which means we will design something and then at a certain stage, we will send that out to all the different specialists. Now, that could be for embodied carbon on one side. How well performant is this going to be? Could be cost, could be anything, could be program. All of these kind of things we find out after a design is done, okay? Now, we will say as an industry, we'll take those results, then we'll regurgitate the design, but actually that doesn't happen very often in reality because there is a cost implication and a time implication to redesign, okay? You have to have some really bad results to impact that design again. And the reason that we do that is simply time and process and a lack of autonomous kind of nature of digital technology. So it takes a long time right now for us to calculate what the embodied carbon will be in a building. That's done by a specialist that is not normally in the same house as the architect. Yeah? So the very nature is that info exchange that we send out. You touched on this with using your database, okay? So what happens if I add another story to this building? Yeah? What does that do to my embodied carbon? They should get this real time. If they get that real time when they come to us as clients, we already know most of these tick boxes have been done. Yeah? We've got an informed design that we can talk on very early days. Okay? And from then it becomes very inclusive. We've been part of that journey. We know that the due diligence has been done on all of these key areas for us. It's meeting our baseline. Our definition, again, can be clearer all the time. And then finally, what we're looking at then is regurgitating what good looks like. So if we have a design that's hitting all of our targets, we can put that back into the database and it should be able to inform even greater design as we go forward. Now, for us as a client, our focus is not speed, fees, or anything like that. We care more about cost certainty than we do about cost reduction. What it should mean for us as a customer-based business is a better design at the end of it. And that could be, as you've touched on as well, Richard, it could be looking at our data from clients. You know, we've got 135,000 homes right now. We could be drawing that information from them. What is good, what is bad? It's actually what we think is good as an architect. The guys living there for the last 30 years might disagree. The extra square meter in your kitchen doesn't really matter as much as the fact that you've got to switch the heating on for 6 months of the year because your fabric is freezing or you're north facing. You get what I mean? Yep. So that's mainly our focus, and I'm happy to say, I've been talking about this for 10 years now, but I'm happy to say the technology is here now, and it is catching up to give us these tools. So for our architecture partners in the room, that's what we're looking for of Clarion, is people who will embrace that change, because it is a big disruptor. It's a big change from how people have done things for generations.
Absolutely. All right, I've been given the 5 minutes left, little postcard popping up. So I've got one kind of question for Rajesh, and then potentially get on to the 3 actions, and if there is any questions, please do sort of make yourself known. We touched, in my kind of briefing note around generative design, you were talking about stage 2 onwards. We're thinking 0 to 2 on that generative design. Something that I've utilized and tested is Google's system Delve, and we spoke earlier, Rajesh, that it was quite interesting. That's very much that running through tons of different options, and then ultimately coming out with an outcome that on a site, one of our sites is actually under construction now, came up with a very similar answer to what the architect did, which was just a really interesting outcome. But Rajesh, potentially, maybe you could just very briefly give us a summary of your use case for that product, obviously on a large master plan up at Wembley, and then if that's something that you guys are using more, or maybe not realizing the value from that, but perhaps touch on that.
Sure. We trialed it for roughly 1,100 unit development at Wembley Park. And the tool and the potential is phenomenal, but our experience really was that every step of the way you have to put in a lot of intelligent information into the system. And for example, what's your parameter box? You know, how do you want the mix to work? Do you have any layout constraints? Do you have any local planning constraints? Sunlight, daylight? And it may sound very simple, me spelling this out in, you know, half a minute, but actually this took us weeks and weeks of meticulous data collection, data entry into this sort of black box in a way. And I think about 8 or 9 weeks into this thing with, you know, all the variables in a sense, it could then generate, you know, scheme design. The challenge then was you then have, in a sense, you know, millions of options in terms of scheme design. What are you trying to solve for? So the question is coming back to us, do we want to solve for highest number of units, you know, profitability? And even once you put in there, you get a myriad of options. And the flip side, which we're talking about, is, or you go to an architect we used, you know, many years along the journey, who understand, you know, those variables intrinsically. They work with us, they work with GLA, other planning authorities, and you get, to your example, more or less the same point again. And so I think the potential is there. It just needs a lot more data, a lot more years of information to get there. And then probably one other point to add is a lot of what I talked about is static information. Things like construction costs, revenue information, they're changing all the time. Unless that's collectively available, you'll never get the most optimal output coming through.
Mm-hmm. Very interesting. I will shout if there's any questions from anybody. Otherwise, I'll probably sum up and give the 3 action points. I think it was not actions, not just words. So I think we've heard today excellent presentation from Consigli in terms of that, getting into actual digital construction and the use of that into operations. Great example there, Rajesh, in terms of how Quintaine's got a lot of data to do something with, and probably pockets of it become more and more effective as you sort of pull it all together. But it's quite the orchestra. You've got to choose which instruments are the best ones to use. And then from Dave's perspective, the reportive design and that evolving into something a bit more reactive and taking a little less time, I think that's a great opportunity. So I think there's sort of harness the intelligence that you get from these great software platforms and some key stakeholders that are using it in a good way. So.